And of course, my video doesn't show me what you guys see, so bear with me. I'm getting the laptop going at the same time. All right. I take it people saw the videos, yes? For the session 3. Yes, no?
Yes.
Okay. All right. So there, it's out there. Also, I added a little bit of log out there if you didn't do it, because there was one problem I got to look at. Ooh, I didn't do an example, so I did do that. So, but we're going to hit 12.6 and 12.7. And 12.6 and 12.7, not much different. They're both are systems of equations. And if you're following along with the fill in the blank, it says substitution or elimination method. Use a graphing to find where they cross. All right. But we start out, hold on. Come up here, buddy. Can you guys see me on video?
Yes.
All right. This is who's being a pest because he's wanting to get on video. That's Gizmo. That is a 15-year-old Papillon. He's sitting here pawing and trying to do everything he can to get on my lap and be a nuisance. So, but I'm going to start right off with here is our system. Now, here's the difference with these systems of equations. Please note, they're not all linear. In this case, we have a linear and a parabola. So they should cross potentially in 2 places. We can do this with substitution, or we can do this with elimination. Personally, at this point, looking at that minus y and minus y, I'm going to do mine with a substitution. I'd rather substitute that linear in to the quadratic. All right. I'm going to substitute in for the y. So that means I need to rework this one to become y equals. So I can move the -2 over, and I end up with 3x minus y plus 2 equals 0, and then to move the y over. This gives me a chunk to embed into the second equation, same type of steps to solve. So what do we have? The part that I'm embedding now, or substituting. Distribute. The part that I'm distributing is that minus. It's kind of a -1. All right. Now I have 2 choices. I can see if I can factor. Really don't want to complete the square on this one because of the 3x, the 2 3x's. Well, I could, but let's see, does it factor? See, 3 times 2 is 6, and 6 factors at 6 that subtract to 3. Well, I can't think of any. Because I see 6, well, 6 and 1 gives me 5, and 3 times 2 gives me 1. So yeah, no. So it means we're going to have to do something different.
I think the 2x squared, the 3x squared should be 2x squared.
Oh, that would be nice. You're right. I'm looking right at it, and I had the three on the brain. So now it does factor. That's a good catch. Factors of 4 that subtract a 3. Well, that's 4 and 1. So factors 2, 1 and 2. I know I need a negative 4, so 2x times 2 gives me a negative. That makes him the positive. All right. So x equals negative 1/2, and x equals 2. So the points that these two cross is negative 1/2 and 0, because the equation itself is set equal to 0. Or I can plug back in. Let's plug it back in. So C, let's do it into the bottom one. I don't like that fatty marker here. So 2 should equal 0. I'm out of room. So 1/2 squared gives me 2 times 1/4 now. Minus negative 1/2 should be positive 1/2. And we got math there somewhere. Anybody see it? Because that gives me a positive 1/2. 2 times 1/4. So where's our math error? Three x minus 1/2 equals negative 2. Move it over as a positive 2. Move that over. All right. So my red equation looks good. And I corrected the 2x. On the second step. Let's go ahead and correct it there. All right, 2x squared, negative 4 plus 1 gives me negative 3 minus 2. And the negative squared does become positive. And I know that doesn't work. Oh, I know what I did. Duh. I gotta get out of stat brain. What were we trying to solve for? Y. What did I plug in for? Y. So negative 1/2 squared gives me 1/4. 2 times 1/4 is move the y over. So we get negative 1/2, 1/2. for my 1 point. We repeat this. You guys want to do a screenshot? This is the bad part about doing Zoom. It's not enough area. I'm waiting, give him time because I can't tell who's writing, who's not. All right. So let's now solve for when I have x equals 2. I'm cheating. I'm using the one where y is already set equal. So that gives me 6 plus 2 equals y. 8 equals y. So when x is 2, y will be 8. This is the 2 points on the graph that the 2 will cross. All right. I'm looking at the form again. But that's the algebraic with solution with substitution. Now, graphing, as much as it's going to pain me, I'm going to do it on Desmos. And that's what I'm doing. I'm bringing it up. All right, why are you not letting me flip? All right, question time. Can you guys see Desmos?
Yes.
Okay. All right. So I need to put it in. My first one is 3x minus y equals -2. And we have a 2x squared. All right. There it is in Desmos graph. Do you believe we had -1/2, 1/2? That's the vertex, and 2 and 8. On the test, beware, it's going to say must show work. So I know you guys can key it into your calculators. You can and such. Got to show your work. All right, let's look at another one. All right, guys can see the whiteboard again.
It's just a black screen right now. Oh, never mind. It's back.
Okay, just a little bit of a lag. Okay. All right, the next one is the x squared plus y squared. So this time they're saying to solve by elimination. Well, again, just like with the linears, to be able to solve with elimination, it means we got to eliminate one of those variables. Can't do the y because we get a y squared and y. So it means I have to eliminate the x squared. Decisions kind of made for sometimes we're limited. So to be able to do that, I need one positive and one negative. I'm going to go through and multiply the bottom one by -1. So I end up with x squared plus y squared equals 13 on top. But now I got a negative x squared, and negative times a negative gives me a plus y equals a -7. So when I add, x squared minus x squared gives me 0. I can't add y squared to y exactly. So both terms now come down. And 13 minus 7 gives me 6. I have a quadratic. That means I need to move the 6 over. Or if you're okay with fractions, we can complete the square. But this does factor nicely. So I'm moving the 6 over by subtraction. So now I'm subtracting 6 from both sides. Now to factor. Factors is 6. Let's subtract to 1. Well, that's 3 and 2. I know the 3 is positive because the middle term is positive. All right. So solve each one. And then we go back for the y's. But be careful. Unlike linear and the systems of 3, we knew how many answers for each variable we could come up with. This is when we start getting where we can have 2, 3, 4 answers. So let's plug this in to the minus y and solve. So x squared minus -3 equals 7. That's a double negative, so it becomes plus. So it's x squared plus 3 equals 7. When I subtract the 3 off, x squared equals 4. Square root both sides. We have 2 answers potentially for x. So at -2, y is -3. And at +2, y is -3. I now need to repeat this with that y equals 2. You're going to find we have 4 answers for this, not 2. All right, take a screenshot if you need to. I'll stall for a moment. Because I'm going to do the same thing now. With the 2. So plug the 2 in. X squared minus 2 equals 7. Add the 2 over. X squared equals 9. So x equals, again, plus or minus 3. So I get square root both sides. So I have a potential for a -3 and a 2, and a -3 or a +3 and a 2. There are your 4 answers. All right. Let's look at this on Desmos. Come on. I got a spinny thing. All right, where's my Desmos? All right, again, I'm at Desmos. Can you guys see Desmos?
Yes.
Okay. All right, x squared plus y squared equals 13, and x squared minus y equals 7. There you go. There's our 4 answers. It shows you how the parabola does cross 4 times. Can you think of an instance where you can have a parabola in a circle where it wouldn't cross 4 times? Thoughts? How about when the vertex is inside the circle? All right. So let's look at the next one. And since I've got Desmos up instead of keep flip-flopping back and forth, let me just go ahead. Let's graph this. I have an x squared plus y squared equals 49. This time, it is a y squared minus 6x equals 49. Parabola on its side. So again, we should get what? 4 answers. But look at these. Look like we're going to get nice answers all the way around. Not on one of them. All right. Anybody see this?
Yes.
Whiteboard? Okay. All right. This time it just says algebraic solution. So we could do it by what? Elimination and or substitution. I'm going to do a substitution for once. See how we have a y squared and a y squared? I can actually substitute in the bottom one into the top one. Since these terms are the same, since they're both y squares, I just need a y squared equals. So I'm going to add my 6x over. I end up with y squared equals 6x plus 49. This is what I can substitute into the top one. So x squared plus my 6x plus 49 equals 49. Clean it up. Subtract the 49 off. When I do, I end up with just x squared plus 6x equals 0. Now, factoring this, I can factor out an x. So my two x values is what? X equals 0 and x equals -6. Did I lose anybody on that? If so, speak up now, forever hold your peace. Because the x, the one most people miss is the x in front of the parentheses. All right. Now I got to plug back in and solve for my y. Just like we've been doing. Again, we graphed it first for once. You saw how many answers we expecting? 4. Ooh, what color haven't I used? I haven't used that color yet. All right, so, ooh. So y squared minus 6 times 0 equals 49. So y squared equals 49 square root. So y equals plus or minus 7. So I did that by plugging in 0. I end up with a -7, a 0, and a +7. I do not write well with my finger. All right, do it again. Y squared equals 6 times -6 equals 49, or not equals, plus 49. So y squared equals -36 plus 49, and y squared equals 13. Square root both sides, and that's when we got that funky decimal. What was it? Plus or minus 6.33? I forget. You guys, I don't have a calculator out, so I'm assuming one of you guys have a calculator. What's the square root of 13? Wakey, wakey out there in Cyberland.
I got like 3.60555.
3.065.
No. 3.6055.
Oh, 5. Well, the 5 makes this the 6 right. So yeah. Don't make it round. So then my other is what? -6, 3.06. Because again, that is a plus or minus. And we have a point of -6, comma 3.06. We can take it out more decimals, but this is, if we were to graph this, we really can't graph much more past the 10th. All right. How's everybody feeling on this? Decent?
Decent.
All right. I really need a bigger table. I'm not used to. All right. So the last example is y equals x squared plus 3 and x squared plus y squared equals 9. Our algebraic solution. What do you think? It's set up as a y equals. The problem is, could we substitute in a y for a y squared?
I think you gotta eliminate the x squareds.
We could do it by that. That means I need to rework the top one, doesn't it? So I'm going to move the x squared over by subtraction. So I subtract it off. That's actually the nicer method, but I'm going to show you how. Yes, we could have actually substituted in. So x squared minus x squared cancels, leaving me a y squared again. Cannot say this is 2y. Nope. One's a y squared. So it becomes y squared plus y. Move the 12 over. By subtraction and factoring. Factors at 12 that subtract to 1. I do see a 4 and a 3. He's the minus, he's the plus. So we end up with y equals -4 and y equals 3. Okay. I now have 2 y's. So I'm going to plug back in. You want to plug in the top or the bottom? I'm going to actually plug into the top. And there's a reason. You'll see it quicker. If I plug in -4 equals x squared plus 3, move the 3 over so I enact the square root property. When can I take the square root of a negative number? Can I? It's an imaginary number. So that means even though we did the math correctly, it's a fictitious answer. So now I'm going to do the same thing again now, but with the 3. Hit the wrong thing. So this time I'm going to plug the 3 in. I subtract the 3 off. I end up with x squared equals 0. So x equals 0. There's no plus or minus 0. We have a quadratic with a parabola, and it's popping saying there's just one answer. So now when I plug in, I've got 0, 3. Let's look at him graphed. All right. So the top one is y equals x squared plus 3. The bottom is an x squared plus y squared equals 9. There's only one answer because this is what we consider tangent. The parabola just barely touches the circle. So we have one answer, not 2, not 3. Linears, we tended to always have just one. Now we're starting to get in where we have multiples. All right. Example 5, I'm really not going to do because there's not something like that on the test. So how are we feeling on 12.6? Questions? No questions? Are we snoozing out there?
No, no questions.
I think they're snoozing. All right, let me move this for a moment. Let's go 12.7. And 12.7 is graphing inequalities. And I'm just going to automatically try to make this as quick and painless for everybody as possible. Do we need to refresh on individual graphing of inequalities?
I don't think so.
All right. Tell me there's a lag. All right, I'm going to actually scroll down to example 2, because example 2 is a graphing of a nonlinear inequality. And we tend to pick a point when we're graphing these. So we end up with y minus x squared less than -2. That's a lousy less than. Well, I want to become y equals because it's easier to graph. So I'm moving the x squared over. Reason being, I know it's a parabola, and I know the vertex. It's using transformations. Since it's not in with the power, it means I just got to move the normal parabola down by 2. This means I got a point there, point there, point there. Only problem is I just goofed. Drawn my finger. It's supposed to be a dashed line. Because it's just a less than. Less than or greater, dashed. If it has an equals with it, solid. So as a reminder. All right. So we pick a point to test because also for inequalities, we need to shade. And the point we tend to pick is 0.00, the origin. It's the easiest one for math. So if I plug in 0, 0, I get a 0 less than, well, 0 squared is still what? 0. So 0 is less than 0 minus 2, which is 0 less than -2. Is that a true statement or a false statement? Because if it's a true statement, we shade the area that contains our test point. If it is a false statement, we shade the area that doesn't contain. I do believe 0 is bigger than -2. So that means I cannot shade that point. I can shade this. All right, I shade the side away. So that is a quick for inequalities. And example 3 is shading system of 2 on inequalities. All right. Now I can graph these. How do we want to graph them? Because that's what it starts out with, graphing, because it's the ultimate thing. So personally, I always like graphing by slope intercept. So I'm going to move both of these over. There's more than one reason why. So I end up with y less than or equal -3x plus 5. And I get y less than 2x. Well, that's a greater than. Minus 10. All right. All right, so I'm going to graph him in red. And I start at 5. And it says down 3, right 1. And this gets a solid line. Now, here's the part of the reason why mathematicians like graphing by this when we're doing inequalities. As long as it's y equals, that type of format in the slope intercept form, if it's a less than, we shade below the line. If it's a greater than, we shade above the line. I don't have to do a test point. So I'm looking at a less than. So I'm going to shade here. I can still do the test point of 0, 0, and you'll find it's still true. All right. Now graphing this guy. I'm going down -10. And this says I go up 2, right 1. Do it a couple times. Straight line, very lousy line, but, and this time it's a greater than, it means it's above the line. That means I'm going to shade here. Now the actual answer is, where does the red and the blue overlap on the shading? And that is the area we want to come back in and properly shade. Not too terrible for hand drawn. We could have done this in Desmos. But that's 2 linears. Let's talk example 4. Example 4 has 4 equations. Now, that x greater than 0, y is greater than 0, it is mainly saying you're in the first quadrant. That's what it means. It's how we dictate quadrant 1. So we make those 2 statements. X is greater than, y is greater than. That tells us we're only in quadrant 1. So do I need a whole bunch of graphing? Nope. Except I didn't make that long enough. Yeah, I did. And I was reading as x plus y is 24. All right. Now graph the system. I have an x plus y less than or equal to 10. Well, graphing that, this one's an easy intercept. So I plug in 0 for x. Y would be 10. If I plug in 0 for y, x would be 10. So that's the intercept method. So 10 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boom. Put in the test, 0 and 0. Zero is less than 10, right? But this time when I go to shade, I'm not shading past the axis, because of the first 2 statements stating x has to be greater than 0 and y has to be greater than 0. No, I got to stay in the first quadrant. All right. All right, I can do it by intercept method again. Hope you guys following along this real quick. Except I can't draw. Divide both sides. My last step was divide both sides by 2. I got x is less than or equal to 12. Since I'm really solving for a point, we solve it as if it's just flat out equals. We do. So I have a point of 12, comma 0. I do this again, except this time I'm plugging in 0 for the x. Well, 2 times 0 is 0. So I end up with 3y. Divide by 3, and we get so my 2 points is 0, 8, and 12, 0. Well, that was 10, so I know he's 12. All right. And again, it's a less than. Staying in the first quadrant. Now this one, I need to shade where the gold and the blue overlap. Well, they're overlapping here. This makes a 5-shaded design. Can't shade between the blue line and the gray and the gold line because my shading doesn't overlap. But we have a point. And if we continued on with this, we need those vertical points. And this is where solving them by mathematics, because we really need to find where that point is to answer questions. That is solving with your system of equations. All right. So far we've done linears. Oh, come on. And the one thing it's not giving us an example of is what if we had a system of inequalities that wasn't linear? So let's go back to the x squared plus y squared, example 2 on 12.6. So I'm going to make him a less than. And I'm going to make him a y greater than. So I would have to graph both of these. Well, remember, one's a parabola and one's not. And do we remember how we graphed circles in the beginning? We did that way back earlier. So unless it's an x squared y squared, we need the square root of the constant, because that's our radius. Our centers on an x squared y squared is 0, 0. So again, calculator, what is the square root of 13?
$3.605.
So I'm going to say 3.1. Because I'm roughly graphing. All right. Remember, once in this format, my origin is at the what? 0, 0. So that means I got to go up 3.1. Put a point. Go to the left 3.1. Go down 3.1. And to the right 3.1. There we go. Very lousy looking circle. But now if I put the test point in, because I need to shade, and being less than that, if I plug in 0, 0, I get 0 squared plus 0 squared less than 13. Well, that's really what? 0 less than 13? That's a true statement. So that means I'm going to shade the inside of the circle. But that's graphing of a circle from the beginning of the semester. So now let's look at x squared minus y equals 7. That one is a parabola, so I really want it as parabola format. So I'm going to take the y over. And then subtract the 7. Now I can graph that quickly by transformations. Let's just go down 7. And this one says, I had a greater than. Forgot to put that back in. So to check that one, I need a test point. So 0 squared minus 0 greater than 7. Well, 0 squared minus 0 is still 0. And is 0 greater than 7? The answer is no. So that means I need to not graph here, but graph outside. So looking at where does the red and the blue overlay, we got 2 slithers. One is here. And one is here. And that would be the final answer, is 2 green slithers. All right. How are we feeling? Because that is really 12.6 and 12.7 in a nutshell. Are we all right?
Yeah.
Okay. Now, I sent out an email that really only one has answered. And while I've got people here, because I'm about to type it up, I'm going to give you a formula sheet. I'm hoping by now you guys have looked over that practice packet. And the request for formulas so far is this: law of logs, and there was another one I can't think of. What else would people like to see on the formula sheet?
The interest formulas things.
Okay. Basically the things that hit us at the end. What I was, because I mean, there was a lot of logs and you guys didn't get a lot of time to play with them. Any others? You're being awful quiet. All right. That's what's going to be on there. So hopefully everybody knows the other formulas that we've dealt with. Yes? Now, for those who showed up today, you see what I wrote, correct?
Yes.
Yeah, we see it. Yes.
Yeah.
You guys could have copped out. You hung these. There's
Yeah.
9 of you that you've hung tight, clean to the end. So I seen a couple bop in for a couple minutes, couple and then bopped out. Okay. And I've gotten a couple emails saying that asked to record because they're not going to be able to make it. Okay. I don't have a problem recording it. I will put the link out. I will upload this to YouTube. Hopefully YouTube doesn't do what I did the other day. For some reason, I have high-speed internet, and I don't mean just normal high speed. I pay the big bucks for basically industrial, like businesses use speed. Because of some of the stuff that I do subcontracting, I have to have very high-speed internet. YouTube was bogged down, and it took me almost 2 hours to upload that video. And it wasn't that long of a video. So I was pinging high, but yeah, it told me it was YouTube. So I literally just left it set and left and came back late hours later. And diagnostics said it took over 2 hours. So hopefully it won't do that again. And I'll get this upload here shortly. Any questions for me for about Wednesday?
No questions.
Are we feeling decent? We studied over Thanksgiving while we were sitting there stuffing ourselves with turkey.
Nah, I stuck to the turkey. Ain't gonna lie.
You got a couple more days. You've got a couple more days. So I know life is going to suck for a little bit, and that's okay. That is okay. So, all right. Well, I'm going to get off here because I'm going to get busy grading more. And you guys, I'll talk to you on Wednesday.
All right. Thank you.
You're welcome. Bye-bye.